So good morning, good afternoon, everyone, and welcome to the third appointment of the Journal Club of VAC4EU of the new season, in which me, Sim, and Martin are the new organizing team. My name is Giorgio Limoncella. I am a postdoc researcher at BPE in Bordeaux, and the other person in the organizing team are Sim and Martin. Please, Sim and Martin, would you like to introduce yourself?
Yeah, hi everyone. I'm Sima. I'm a new member of the Journal Club, and I'm doing my PhD in UMCU, and I'm also part of VAC4EU. And we are happy to have Davide today for this presentation. Yeah, I think you already know Martin, but I give the floor to Martin.
Yeah, hi everyone. My name is Martin Solórzano. I'm working in EDF Jordi Gold in Barcelona, and also I'm doing my PhD in UMC Utrecht under the leadership of Miriam. And welcome to the Journal Club new season.
Thank you for the introduction. So I'm very glad to introduce Davide Messina, that is a former colleague of mine from Ars, and the Journal Club of today that will be led by Davide. One focus on target child emulation, it won't focus on new methodology to discover some hidden complicated bias, but it will focus on another very relevant topic, that is the transparency, the reproducibility, and the fairness in the process of generating real world evidence. So please, Davide, the floor is yours.
Hi everyone. I'm a statistician and I work in Ars Toscany in Italy, but normally right now I'm working as a programmer. I'm pretty much working towards wizardry on GitHub, about GitHub, but I consider myself intermediate level at this time. So let's explore what this paper says. So transparency and reproducibility, first chapter. Next. But let's start from another article. So the idea was to talk about one article, but we need to start from another one. One of the authors is the same, Shirley Wang, and this is written also with Anton Pottegard. The link to the article is below and it's open. Next. So their idea, it's this one. So we need to have open source studies, because the field is going toward open source. So they're defining different criteria how to define open, like how it is, we say it's open, how it say it is transparent. So they created this table. An echo? I don't know if you hear an echo. Is it?
No, so it's my computer.
Okay,
Yeah,
okay.
I'm hearing
okay.
Davide quite well.
No. Then I will continue. So they define this table. In theory, you should say in each of your study which level you are for that study, and you are at a specific level, you get a badge. Let's say this is the idea of the whole paper. Next. We will talk about a little bit about level 2, which is the minimum level required to get an open badge. So they have 5 different, it disables 5 different rows, which are 5 different categories, and then levels of transparency. So in case of the protocol, the initial protocol and amendment need to be available at link, whatever, it needs to be open source. Registration, again, need to be available. It needs to be per register somewhere, but open. Data available, again, open source at link, whatever, but they are available. Code needs to be available for everything, tables, figure analysis, all codes needs to be there. And then the manuscript is aligned with the guidance from the reporter checklist. The checklist is provided appendix. And this is, okay, this is the level 2 base minimum for all the categories. Next. But we will talk a little bit better about the protocol. So the level 0 is there is no protocol or is not available. Level 1 is the protocol is available upon request, and the level 2 is the one I said before, and the level 3 is just the additional to level 2 is just the protocol was developed using a structural template. But with or without template, you get the open material badge. Next. What it says in the paper regarding the protocol, it says protocol will often require updates. Well, this is obvious. Any improvement or addition should, however, be transparently argued and documented. Next. But then this is the one that is on the paper, but a link in the paper from the Open Science Foundation, which define these badges as additional criteria for these badges. The one on the protocol, which is called Open Material Badge, as this additional requirement. The one is that material must have a persistent identifier and timestamp immutable and permanent. Very important. And then the infrastructure or other components that cannot be shared digitally are described for an independent researcher to understand how to reproduce the procedure and how the materials related to the reporting methodology. This is not very much explained also in the original material. It's very broad. Next. Okay, we talked about the protocol. Next. And now we talk about the code. Level 0 is that the analytical code is not available. Level 1 is available upon request. Level 2, everything is shared. And also level 3 is for also for the analytical dataset, not only for the script in the intermediate and final step, but also the initial step from the source data warehouse, so the ETL pretty much. Next, regarding the code sharing, it requires considerable effort to document the necessary metadata and to maintain analytical code so that it is understandable for investigators outside the project or organization. Next. The additional criteria, again, the code must have the same criteria as before. So this one, I will just skip it because we don't have much time. The code needs to have an open license, very important. And then sufficient explanation is present for an independent researcher to understand how the code is used, including information about version of software, system, and packages. Which is, yeah, it's demanding as it was explained before, but they think this is necessary. Next. And now we get to the main article. Now we have an idea like why we want to use Git and R. Like we have this problem. We need to be transparent. We need to be open source. We need to understand how are we going to do that. So this is the paper that we are going to talk about, the main paper. Next. These are the sources. The full article is available here. The article is semi-open. If you are a ISPA member, it is open. In case it is not open for you, it is built by Quarto and it is on GitHub, so you can just rebuild it yourself. And then I also included a part of a podcast by Yannick Weberpals, one of the authors, which discussed the article. So I deem it like on point. Next. Now, FAIR and why to use Git. FAIR was in the title. Why are we using FAIR? Next. First, let's start with FAIR data, which is a concept which is well defined, and the definition that I will show you next are from Wikipedia. So F, if findable, metadata and data should be easy to find for both human and computer, accessible, the user need to know how they can be accessed the data, possibly including authentication and authorization. Interoperable, the data usually need to be integrated with other data and need to interoperate with workflow for analysis, storage, and processing. Next, and then reusable. Metadata and data should be well described so that they can be replicated and or combined in different settings. This is FAIR data. So what they say in the paper is we start from FAIR data and then they create a new concept next, which is FAIR code. Let's see how it is different. Next, it is again findable. You need to find where the code is stored. Next, accessible, needs to be open source. You need to be access this code. Interoperable, so it means that in this case, minimal or no changes need to be done when running on a different machine, even by the same person. And then reproducible, so it's not reusable as data. They change it to be reproducible, but it's still fair. Yeah, start with an R. It means same input means same output. Finger crossed always, but yeah, that's the idea. Next. Now, we have this fair argument for transparency, but again, how are we gonna do that? Version control system. So version control system of VAC4EU provide powerful tool to keep track of versioning of important file and documents such as protocol, analytical code, tables, and figures. Next. But now, why using a VAC4EU in general? So let's start. We have a folder. We have a folder we've done analysis in the past, but we need to go back again because maybe you need to change something. But you don't remember what you have done. You have a lot of files there, one analysis, but you don't remember which one you need to check to change. Next, you start from this draft analysis. Then you have the complete analysis. Next. Then you have a final analysis. Well, it's after complete, you know yourself. Then it's finalized, right? Yes. Revised one, yes. Revised one, additional changes, yes. And then you have final analysis 2. Where does it go? Is after final analysis next? Or maybe it's after the last one. Let's say it's after the last one next. Let's say it's there. But then you have final analysis with bug fix. What are you gonna do next? Let's see where it goes. Well, it goes there next. Or maybe it goes there. We don't know. Maybe it's the last one. Let's say it's the last one. Yes, next. And then you have final complete analysis. Now, where does it go next? It goes there, maybe there, next, maybe there, or next, maybe there. Maybe it's the last one. We don't know. So what are we gonna do next? That's why we need a VAC4EU. VAC4EU can extend the principle of fair data to the implementation of pharmacoepidemiological study workflow by making all components of a study fair. So with a VAC4EU, you can comment, track, and compare changes made to files, increase the ability to comprehend the evolution of a project over time, and maintain a complete audit trail of changes to all documents. That's very important. Before, you may know before, in the example before, what was the last document, but maybe you don't remember the order. And in some of the project that you're gonna do, it's very important, the order, because you may, the company that is giving you the study is saying, well, we want to know why you have done these changes and when you have done it. And if you don't know, that's a problem. Next. So now Git. Why Git? Because it's a VAC4EU software. It was developed by the Linux developer community in 2005 because they said, okay, there are already VAC4EU software. We don't like them. We are going to create it for ourselves, for the Linux project. This is kind of important. We'll see why later. The way to conceptually think about Git is that it makes a snapshot of your repository where the project is stored every time you want to save a state of the project. And it can be seen as a time machine that enables researcher and developer to compare codes and repositories across different versions over time. And you can go back in time, change something in the past. It's not a problem. You can think it's a time machine. It's a common example. Next. And then we have remote repository platform. So Git is almost always used in combination with web-based repository hosting services such as GitHub, but it could be GitLab, Bitbucket, there is many of them. Advantages, why are we going to do that? So this way, it is possible to synchronize local Git repositories across multiple project members. So it improves collaboration. If you're going to work alone, well, it's not useful. If you work with a team 2+, use a remote repository platform, always. And then it complements Git functionality by providing graphical user interface to visualize changes and then offer advanced features such as automation of workflow or AI-powered virtual code assistant, for example, GitHub Copilot. Next. Now, the paper then delves very in-depth about Git. It says also how to install, how to set up, how to do everything. We are not going to do that because we don't have much time. So what we're going to talk about is the Git workflow in general. So this is the basic, very basic Git workflow. You start from the file changes at the top. So you make a change to whatever you want. Then you say to Git, yeah, I want to save this file. To do that in Git, to save in Git, not in window. First you save in window, then you save in Git. You save in window, so the file has changed. Git will say to you, okay, this file has changed, but by default, it will not say to you, you need like save it now. You need to decide it when you want to save. You may say to Git, you modify to file, I want only save only once, only one of them. So you select only one of them. So when you say to Git, okay, I select only one of the file through the stage, then I want to save it in Git, you do the commit. The commit save a local snapshot of what you are put inside the stage, pretty much. And then after you have committed, Git will make it like disappear in the file that you have changed. So to Git, it says pretty much up to date. There is no changes. You can't commit something that is not changed. You need, well, you can wait, but in theory, the idea is that you push to the remote repository, because right now you have saved a local snapshot, it's local. But if someone else needs it, very much possible, you need to push to the remote repository so it is synchronized. And if someone else has made other changes and they are made their own push to the remote repository, you need to pull the changes. So you need to get the changes in your PC. And in theory, if you're working on different files, two persons working on different files, push and pull, not a problem at all. Git understand how to work on different files. Working on the same file on different lines, it's not a problem. Git understand what's going on and changes if you pull, it changes the files automatically, even if you already changed it, but on a different line. If it's on the same line, then Git doesn't know what to do. But it will not fail badly in the sense that it will give you an input and says, okay, there is this conflict, go to the file, I will give you suggestion, you need to decide option 1, option 2. You decide, you change again, you commit, you push, everything is fixed. This is the ideal way. Next. I want to add to this workflow a little bit. So another important part, I will not go very far, but Git tag is just a bookmark for a commit. Very important commit, you can just make a bookmark through Git tag. Next. One of the main motivation to adhere to this workflow is that in return we get a detailed audit trail of changes made to our study files. And the best way probably to visualize and track changes is with the remote repository. On the right is an example. You see the commit, the token, the changes to be that has been done, and the figure from before and after. You can really see what the commit did, and you can do that for each commit. Next. Now, Git ain't all sunshine and rainbows. We are not gonna say that this is the case. Next. But we are gonna get some solution. So, first, documentation. In the paper, it says that being transparent about data provenance, pre-processing step, and operationalization of exposure outcome and covariates is of critical importance and should be part of the repository metadata. And then this can come in form of codebooks data dictionary, literate program script like Quarto, or other applicable documentation files. So they are saying this is important documentation. Next. But we have a limitation on through Git, because Git was primarily designed to work with source code files. Again, it was built for Linux. So the limitation is when it comes to tracking binary files, such as Word and Excel, for example. If you open it through Notepad, you won't see what's inside. You will see like garbage because it is compressed. You need to use a specific software to open it and really see what is inside. So while Git can still be useful to track version of these file types, you can do it, but you need to recognize that modification in such a document cannot be easily be inspected through RStudio or GitHub. You can't see the difference between two different files. You just know that the file has been changed. You can go back to a previous version, not a problem. You can do whatever you want. You just don't know what is the difference between version 1 and version 2. You just know they are different. Next. Now, let's go back a little bit on the additional criteria for badges. So what they say is that materials or code needs to have a persistent identifier and timestamp immutable and permanent. They need to be in that format. Now, let's see the table below. We have provider, persistent identifier, timestamp, immutable, permanent. Now, provider is GitHub, and then next we have Zenodo. Now, let's see persistent identifier for GitHub. Yeah, not so good. Zenodo is good, yes. Timestamp, good on GitHub. Zenodo, yes, is good. Immutable, no, not so much on GitHub. Yes, is good for Zenodo. Permanent, no, for GitHub. And yeah, okay, for Zenodo. There are still problems also for Zenodo, but yeah. Now, creating persistent identifiers. You can go now. Yeah, thank you. A cornerstone of FAIR principle is the use of persistent identifier for enable fundability and accessibility of a search object. And Zenodo allows users to share diverse research artifacts. The platform can seamlessly interface with GitHub, enabling the creation of referenceable DOI for existing code repository, but you can use it also for the code books, for example, or other documentation that you want to document and made it open source and transparent. You need to have a DOI. GitHub, as we've seen, is not enough for that reason. Next. And then additional consideration. So while Git offers substantial benefit for collaboration, reproducibility, and transparency in real-world data teams, real-world evidence teams, challenges can arise in its adoption, particularly related to the merging conflict, as we've seen. It's maybe a problem, but normally not. Steep learning curves and maintaining consistent user practices across team members. It is advised to, my advice is to take the course on GitHub available from VAC4EU. VAC4EU has a course on GitHub if you can take it, because that's point one. I will close the presentation with this phrase. This is from Janik Weberpals, one of the authors. This is also food for thought, let's say, for the discussion list, in the sense that if people provide code to implement a methodology, then you can just basically grab the code and implement it in your study. If it's open source and transparent, obviously, that's the idea. And next. Yeah, thank you. Pretty much this is the last. Any question, thoughts about this?
Thank you. Thank you very much, Davide. It was a great presentation, really clear and interesting.